Hello, everybody. Thank you for attending this session. This is the future of ALS research, hope, and data. A very interesting session for me. I am a volunteer with I Am ALS. I am a NEALS research ambassador. I'm a caregiver to my husband, Ron. And I have a 6-year-old granddaughter who wants to come up with a potion that will make Papa walk again. Only downfall so far is every potion has glitter in it. And I have to explain that Papa cannot drink or eat that. So, but she's trying. So we need to progress this a little further. So maybe when she gets a little older, she can be involved and come up with something. So research is the engine that drives breakthroughs in the movement to end ALS. But interventional clinical trials are not the only way that research is done. In this panel, experts will unpack the role geomapping and natural history research has in transforming ALS from a fatal diagnosis into a manageable condition. We'll explore what research looks like and how you, all of you, can get involved. We are going to start with Cassandra Holmes. Cassie is a clinical nurse practitioner passionate about neurology and clinical research. At a young age, she became fascinated by the neurosciences through her own experiences as a pediatric neurology patient. She received her undergraduate degree at William & Mary. I think we have a few other people in the crowd who did as well, in neuroscience, and completed her nursing education at VCU and Georgetown University. She was recruited to NIH as a clinical research nurse practitioner and worked in inflammatory diseases and dermatology for 4 years before returning to Georgetown University, where she now works as a nurse practitioner fully dedicated to ALS clinical research. Welcome, Cassie.
Okay, thank you guys for having me here today. So we're going to start with natural history studies from observation to innovation. And I'm going to have to talk a little faster than what I'm used to. I'm originally grew up in the South, so I like to take it slow, but oops. Okay, I think I figured the clicker out. Okay, for disclosures, I have no financial conflicts of interest to disclose. I am employed full-time by Georgetown University. And so let's get started. So first we'll start with the basics. Probably all of you know about clinical trials, or what we call interventional studies. These are kind of what people think of as like the classic experiments where a group will receive treatment like a drug or a medical device, and then you study what happens as a result. The gold standard for those is often talked about as being randomized. So people either randomly get placebo or drug treatment or other therapy, and then double blind. So patient and researcher don't know who's on the placebo or the drug. But we also have what's called natural history studies or observational studies. These can be longitudinal, where you observe a group over time, or retrospective, where you look back, like, for example, at many patient medical records after the fact. No treatment is administered experimentally as a part of these studies, but they're very important to our understanding of disease and treatment of it, as we will learn. So let's first start with the history of natural history. So in 1945, FDR died of stroke. On the day he died, his blood pressure was 300 over 190. Today, we consider 120 over 80 normal. In his time, it was actually considered normal for blood pressure to increase with age. And so when his physician finally started to think, well, maybe his blood pressure is starting to be a problem, it was already too late and they had no tools to actually treat the blood pressure. So by the 1940s, cardiovascular disease had already become a leading cause of death, and we had little ability to prevent or treat it. So in 1949, researchers decided to follow families in Massachusetts over time to learn more. And this today is known as the Framingham Heart Study. This natural history study revolutionized our understanding of cardiovascular health by identifying the role of blood pressure, blood sugar, cholesterol, and smoking in cardiovascular disease, stroke, and dementia. So the study is actually still ongoing today and enrolled its 3rd generation in 2002, and it's expanded a lot to include genetics, machine learning, brain donation. And so many of us have never heard of this natural history study, but it's changed all of our lives and our understanding of our health. And so let's look at an example closer to ALS. So what about other neuromuscular diseases? So in 2006, the FDA approved Myozyme for Pompe disease, and there was no placebo group and no blinding. And this is a disease that is a rare genetic neuromuscular disorder that can cause weakness. And so how did they get this approved? So basically, to compensate for the rarity of this disease, they used natural history data that was collected over 20 years to serve as a control group for the patients receiving the Myozyme drug. And so the FDA ultimately accepted the company's submission for Myozyme approval. And so what a lot of people don't realize about natural history studies is that we can use this data to help bolster our understanding of the disease and drug finding. So let's look at ALS. So is there any kind of comparable example in ALS? So in 2005, Jamie Haywood, who's a mechanical engineer from MIT, founded Patients Like Me after his brother was diagnosed with ALS at 29. And so Patients Like Me is an online community for people with the same disease so they can connect and collaborate. And so Haywood and his team had the foresight to build in collection of real world data to patients just like me, so people could upload that to the site. And so around this time, there's interest in lithium for ALS as a treatment, and lithium was already an established drug. So a lot of ALS patients began receiving it off label, and a lot of those patients were actually part of Patients Like Me. So basically, by utilizing the Patients Like Me database, Haywood and his team were able to compare those patients on lithium to the patients who were not. And that initial study was very low cost and actually incentivized and inspired subsequent randomized interventional trials for lithium in ALS. And so while Haywood and others have overall demonstrated lithium was ultimately unhelpful in ALS, they still use this experience to keep trying. And so in 2014, they started an official natural history study that's known as the Precision Medical Program and has evolved into the ARC study. And they have funded that through the Ice Bucket Challenge. And so let's talk in some more detail about challenges facing ALS research and how natural history studies fit in and can help us meet those challenges. So first of all, like Pompe disease, ALS is rare. So that means there's less patients, it's a little harder to recruit people, and the more patients you have, and usually the more people involved in a study, the stronger your mathematical findings. And the FDA wants strong mathematical findings. So that's certainly a challenge when you're talking about rare diseases. And so the good thing about natural history studies is these can help us kind of combat that in two ways. So the first is there's already a precedent for what we call external control groups. The Myozyme study is an example of that. So basically, you can use the data collected on natural history studies to serve as a control. And then another exciting kind of upcoming thing that we're looking at now is called virtual controls. And so virtual controls are generated using advanced statistical techniques based on natural history data. So by using natural history studies down the line, we might be able to use virtual controls to hopefully decrease the number of people on placebo in trials and increase the number of people in the treatment groups, which should hopefully translate to more life saved, more people getting treatment. So second, we have heterogeneous population as a challenge, and natural history studies are designed to study this. So as we know, some people have limb onset, some have bulbar onset, some are upper motor neuron predominant, others are lower motor neuron predominant. So ALS patients can look very different from one another, and we need to understand that. And so natural history studies allow us to look at data for each case, understand and study these disease patterns. And drug trials are not designed specifically to fully capture or study those kind of differences. This is really what natural history excels at. And so also what's helpful is that patients, when they're on natural history studies, it does kind of facilitate sharing of findings about unusual cases and things like that, because the doctors who are involved in these studies, if they're patients on a natural history study, they already have approval to kind of share that information about these cases and publish accordingly so more people can know about what they've seen in clinic. And then, oh, sorry, one last part. Also, I wanted to point out that drug studies are exclusive and natural history studies are inclusive. So natural history studies have less strict enrollment criteria because they want to capture everyone with the disease to get a good understanding of it. Whereas drug trials, they're intentionally set to be more restrictive of who can join. So for example, as you guys have probably encountered, many drug studies want symptom onset of 24 months or less, and that excludes a lot of people because what about slow progressors? That you can't join those types of studies. But natural history studies, you can still become a part of and invaluably contribute to research. And oftentimes you can see in medicine, breakthroughs will happen from unique cases. It's not always the standard cases. So that's why collecting data on natural history studies is really important. And then our next challenge is funding. As you all know, I'd like to thank everybody here already for your tireless work to really make adequate funding for ALS a reality. That's something I've always been really impressed by with IMALS. One cost-effective way that we do have in research is repurposing existing medicines. This is cheaper because we're not starting from zero. We already know about some of the drug safety profile, but pharma companies aren't always in love with that because it's not quite as lucrative as a brand new drug. So how do we make these kind of studies happen for repurposing existing medicines? Well, sometimes we can use natural history studies to leverage this. So for example, the lithium discussion that we had earlier kind of used the natural history study to then inspire people to invest in interventional trials of lithium later. And then also for funding, we can save money through use of external controls and virtual controls, which are built and strengthened through natural history study data. And then, so I'm going to skip part of this. We'll skip blood-brain barrier because that's fine. We have to move on for time's sake. And we'll talk a little bit about CSF. So ALS is a challenging disease to study just because of the nature of disease. So CSF is the cerebral spinal fluid that surrounds the brain and spinal cord. It's not equivalent to your blood. There's possibly molecules in there that might hold the key to understanding this disease better that we can only find there. So obviously, because we have to get CSF through a lumbar puncture or spinal tap, which is harder than a blood draw, it's scarce. And we have to take care of those samples because they're really rare and important. So how can natural history studies help us do that? So first, I want to go over in vitro versus in vivo studies. In vivo studies are the studies that occur in living people or animals, so organisms. And in vitro are in the petri dish, in the test tube, just cells in a tube, basically. The in vitro, the test tube and petri dish studies are really important for us to do before we are allowed to try any drugs in people. And a lot of the times, those in vitro samples can come from natural history studies. So that's where we collect that initial sample for science. And then, like I said, CSF is hard to get. So large-scale natural history studies using biobanking can improve our access and use of the CSF since it's so important and precious. So let me paint a picture. Say I open an ALS study at Georgetown to look for molecule X, which is not a real molecule. I'm just using it for example. I'm lucky I have an ALS clinic. Not all ALS scientists do. I spend hours recruiting patients in clinic, and then I also need people with advanced clinic and lab skills, and I have to pay them. So let's say it all goes well, and I have samples left over. They're in my lab freezer. No one really knows about them. And even if they did, I'm not allowed to share them. Because legally people only consented to my study. But what if we could fix that problem? So that's really what these natural history biobanking studies aim to do. So multiple sites across the country team up to collect CSF and blood and urine and then store it at a central lab so researchers can apply with their project ideas, and then the study leaders review those and then approve the best projects. So if you want to study molecule X, but you don't have a clinic or you don't have that much money, but you have a good idea and the right skills, you can still do that. So Natural history studies are really important because they bolster our drug study data. They give us a better understanding about the factors driving the disease. They promote kind of the in vitro testing prior to us moving to in humans. They maximize our use of these biological samples donated to research through biobanking, and they save lives by generating data to support virtual controls. And so how can you help? I think the whole point of this is join a natural history study. Many also accept healthy volunteers. So you can participate in these even if you don't have ALS. And that's, I think, really important because if we don't have a baseline healthy control, we don't really know what's normal versus not normal. Funding can often be challenging to secure. So also just important to advocate to others and kind of push these as well. We often have to use funding from either philanthropy, foundations, or government to fund natural history because they're not really drug sponsor funded. And then also, if you are already in one, I would like you all to give feedback. So definitely share with your research team how they can make it better, ask for like them to share results, because I think that's really encouraging if you're already participating in this study. And then I would like to jump into a little bit on All ALS, which we have Emma from All ALS here as well, which is one of our natural history studies available in the States. So there's two arms to All ALS. There's the assess arm, which is vital data on people living with ALS and healthy controls to track disease progression. And then we have the prevent arm, which help us understand the earliest stages of disease in people at risk. So those are people with strong family history or a known variant. And so the goals of All ALS are to accelerate the research outcomes by collecting these large amounts of data to share with researchers, kind of like the biobanking we discussed earlier. They integrate the data to hopefully fill in gaps in our natural history knowledge. There's a huge community aspect. There's a lot of webinars, newsletter, and social media, which is, I think, really great. And then the accessibility is another key part of All ALS, is that they have 35 clinical sites and you can participate remotely, which I think is awesome. Okay, and then there is our QR code.
Thank you, Cassie. That's good information for all of us. And I really like the line that the drug studies are exclusive and the natural history is inclusive. That's a line that I can use when encouraging other people to join these studies, even if they're not eligible for a drug study. And I also want to recognize Emma over there. Emma Allen, you want to stand up, please? People know who you are from All ALS in case you are interested in talking with her. Thank you. Okay, our next speaker is Danielle Boyce. She is a data scientist and patient advocate working in the rare and neurodegenerative disease space. She is the principal investigator of real-world evidence at ALS, TDI, and holds faculty positions at both Johns Hopkins University and Tufts University. She is also a member of the board of directors of GeoALS, the nonprofit that's dedicated to mapping ALS-related topics, founded by Pat Dolan, a mapping expert and a person living with ALS. Welcome, Danielle.
Shout out to Pat. Thank you so much. I heard, yeah, Pat. That's right. Pat's watching. So speaking of Pat, am I standing too close? There we go. Speaking of Pat, I don't normally speak with a lot of notes, but Pat wrote up some notes and made the slides. So I'm basically just here to be window dressing and speak for him, but he did all the work. And so that's my favorite kind of conference to speak at. So working with Pat really has been the highlight of my nearly 30-year career in research, hands down. And now my daughter, Ryan, here next to me, is the next generation of advocacy and a proud member of the Pat Dolan fan club. And she's our intern at GeoALS. Yay, Ryan! So geography really is the foundation for the next generation of ALS research. This is a really exciting area for me to work in, and I kind of fell into it. I had some epidemiology training, and that was what I got my master's in, but I never really used it, not for something this useful and important. So GIS brings disparate data together by geography to discover patterns and relationships that are never seen before. So what is GIS? So Geographic Information System, GIS, is the technology that organizes data by geography and provides spatial analytics, which sounds fancy, but I'll show you what I mean, to identify those patterns and relationships. So I'm going to give you some examples. Picture says 1,000 words, right? So here's an example for access to care. And these are all maps that Pat and I have worked on over the years, and we have, I'll have a QR code at the end, and you can go to the GeoALS website and see all of this cool stuff that we're doing and get involved and work with us. So this is access to care. So this map shows the locations of ALS clinics and cities in the US. So we use drive time analysis to calculate 90-minute drive time polygons from each clinic shown in the red polygons. So see those red areas? Those are 90-minute drive times around an ALS clinic. The analysis is used to identify the cities with populations of 60,000 or more that are 90 minutes or more from an ALS clinic. So this helps us, if we see that you're in a city that's outside of that, we can say, well, this is an access to care issue. You're not going to be able to easily get to a clinic. That's a really easy but powerful thing you can do with maps. And what we found here with this analysis, this is just a segment of it, was that there are 460 cities. Those are the purple dots. 460 cities with populations of 60,000 or more, with 14.5 million people who are 90 minutes or more from an ALS clinic. For these cities alone, there are an estimated, depending on what statistics you use to estimate ALS prevalence, so there's that, but there are 1,194 to 1,535 people who have a 90-minute or more drive to clinic. So there are 2,000 people who have ALS, by our estimates, who are more than 90 minutes from a clinic. So that's another very useful way you can use maps. And so think about all the other stuff that you can use maps for within, for access. Okay, so then we can do the same analysis for veterans. This map shows the locations of VA ALS clinics with the military veteran populations. This analysis found that there are 8.8 million, 52% of veterans who live 90-minute drive or longer to a VA ALS clinic. That's really powerful, and these tools are by and large built in to the software. You just need to know how to use it and how to put the data into this software. Super powerful. And something I want to mention that we haven't shown here, I saw Glenn Rouse on the in memoriam video, Glenn Rouse, legislative viewer. So something that's not on here is we can, and Pat wanted to make sure we mentioned it, but it's, if you click on the QR code at the end, you can see it. It shows you all about your legislators in your area and all about ALS in those communities. And it's a very powerful tool. Again, overlaying mostly public access data, open source data that you can get anywhere, but you just need to know how to use the software. So this is data science for good. All right, so now, so this is one, and just full disclosure, Pat and I work on a project that's funded by the CDC National ALS Registry Program that I work on through ALS TDI. And so we do a lot of work with place history, residential history. So we talk a lot about environmental exposure. So we're very interested in understanding where you lived when you might have been exposed to whatever it was. And then we have tons of data on a very granular level that describes different environmental toxins and things over time. So we can overlay what we know about where you lived over time with what was going on in your area and understand quite a bit. So this is common lived locations. So we can study the place history of people with ALS to identify common lived locations. This information can then be used to study the environmental conditions in those locations that increase the risk of ALS. So this is just a very simple representation of that, but it shows you your your pre-diagnosis location and then how long you live there. And that's kind of like the building block of our layers of data. You have layers and layers, but that's kind of the start. So if you participate in a natural history study where they ask you what your address was over time and where you moved over time, that's how we use it. Okay, so this is our environmental risk factors inventory. So this shows Superfund sites, toxic inventory release sites, and DOD sites, and this is Philadelphia specifically. And these sites have been linked with chemicals and environmental conditions linked to ALS. So we call these map layers. So if we have that information, then we can overlay it with the data that we have and other combinations of things as well. So if you're, on Medicaid or, different things that we know about you, it can help us to understand visually what's going on. And sometimes people say there seems to be a lot of ALS in a particular area, and we can use these tools to help tease all of that out. This one I think is really compelling, and I'm really proud of this work. This is the work that we did with the CDC registry. This isn't part of our grant that we're working on now with risk factors, but this is, we worked with the CDC registry to help them to understand where they were failing to enroll people into their registry. So how do you know where they're not capturing people? MAP is a very good solution for this. So the map shows the communities that didn't at the time, I don't know about right now, didn't have CDC registry participants. This information is used to focus recruiting efforts and work with ALS clinics in those locations to educate on, in this case, the CDC registry, but it could be any study or any initiative. It could be any data set. If you know where people are, I can map it. We can put that on a map. If you know where nonprofits are, if you know where services are, if you know Medicaid access, you name it, you can put that on a map. And then you can lay it over any other data that you have and tell this compelling story. But this makes it a lot easier to understand where you're missing people in your recruiting efforts. And most of this is kind of open source data that you can access or use from your own natural history study. So this analysis can be enhanced by studying these locations that have access to transportation, to internet, to health insurance, and see if those impact enrollment rates. And that's what we did with the CDC registry data, because this software automatically pulls in this community atlas data and pulls everything up, like census data and Department of Labor and all these things. And it pulls it up and you can say like, wow, right there, the percent of people who don't speak English is this. The percent of people who don't have an internet at home is this. And it really helps and saves money, and you're not just trying to guess where you're not enrolling people. You can also overlay it by population density, percent population who are veterans, to help understand the magnitude, of the effect of under enrollment. So likewise, we were talking about natural history study and the PMP, which is now the ARC. That's a study that I work on at ALS TDI. And so we've moved this into ALS TDI, where we're doing the same thing. And so participants share data about a number of things in a natural history study. We share that data openly on a platform called Looker. And so the ARC data is organized by something called public use microdata areas, or PUMAs. These are non-overlapping statistical geographic areas. I'll give you a quiz later. For each state or equivalent entity into geographic areas. So basically it's a slightly different way of looking at things in zip code or state. It's just a different way of doing it, but they have no fewer than 100,000 each, 100,000 people in each. And this again helps us to understand the communities where they live, where we're doing a good job enrolling. Can also help us to understand, again, environmental factors. Whatever you want to lay over that, now we have this available to us and we can slice and dice it in different ways. And it helps us to understand who's not represented in the ARC study, who we need to do outreach to, where seems to be a lot of places with ALS and what we can do about them. All right, so this is the famous QR code. Pat did this. Oh, I got 5 minutes, perfect. Yeah, Pat made this QR code, and this is our nonprofit that we created just for the purpose of being able to do all of this and share it with researchers around the world. And, with ALS, but also anyone, can access this and participate and use these tools. So it's a nonprofit organization whose mission is to advance the science of ALS through GIS. This is done by organizing data by geography, like I just showed you, to find patterns and relationships, which are used to improve care, accelerate research, and advocate for the ALS community. So GeoALS is powered by top GIS professionals, researchers, and advocates. Hopefully I'll have some advocates who will come join us now. We're passionate about advancing the science of ALS. And Pat made this QR code as well, and the link that it goes to the IMALS forum asking the legislators to continue to fund the ALS registry and other research. So if you scan the QR code, it will bring you to a form to fill out and submit, and it takes fewer than 90 seconds, he says, to fill out. The other thing I wanted to mention is the clinic experience survey that's also part of GeoALS. Pat's group, the mappers that he started, there's a survey. We have QR codes that you can take, and Starbucks gift cards, so see me afterward. You can have, if you want to fill it out, but it maps all the clinics on all the ALS clinics, and people can rate their clinic and describe their experience at the clinic, and so you can see your clinic on a map and understand how other people fared and what they thought of the clinic. So he wanted to make sure I mentioned that as well. So like I said, Ryan and I have cards that you can use to scan and get to that survey. So thank you very much. Appreciate it.
Thank you, Danielle. And thank you, Pat, for making all of the slides. And Danielle was way more than window dressing. And it's always good to see math in action. And you think back to your middle school days and what different path might you have taken had you known that the science and math and geography could all be used together like this. So awesome. Our next speaker is Maggie DeMarco. She is a former full-time caregiver to her father, Anthony, who passed in April from familial ALS with some FTD. Maggie is a professionally trained chef. Her work is rooted in care, service, and a commitment to communities and conversations too often overlooked, undersupported, or stigmatized, both within the hospitality profession and throughout her advocacy in the ALS FTD space. This includes those working in hospitality where high-pressure environments and perfectionism often mask the need for mental health support, as well as families navigating the complex realities of ALS and FTD, both of which reveal where our systems fall short and where deeper structural change is long overdue. Maggie was here with us last year at the summit in person, and her father joined virtually. She credits the IMALS community as a lifeline throughout their journey and is honored to contribute to a future of deeper connection and meaningful change. Welcome.
Thank you. Thank you. Very honored to be here, especially alongside of some very, very intelligent women who are doing so much for research and really leading the way. So thank you. I wanted to start by just sharing this intro slide. This is a few photos of my father and I. Like she shared, he just passed recently, less than a month ago on April 10th, just under a month after his 60th birthday. So I'm here today to share a bit more of a personal perspective to research. And so my name is Maggie DeMarco, like I shared. And before I ever participated in research, it felt very distant, pretty intimidating. There was a lot of big words that I didn't fully understand. And I wasn't really sure how to even approach supporting my dad and getting involved. And so we didn't even actually know my father had familial ALS. We didn't have any really true family history of it. My great-grandmother passed from Parkinson's disease, so which they think. At his first ALS clinic, he wasn't tested for familial ALS, and so it wasn't until we moved to a closer clinic when it became difficult to travel that he did some genetic testing, and that's when we found out that he tested positive for the TAR-DDP gene. At that point, I knew that our story with ALS wasn't going to end with just my father. And so I turned my research efforts into how I could also get involved. And so I immediately wanted to know my genetic status. It's a very personal decision, and I'll go further into that a little bit later. I'm one of 4 girls. I have 3 sisters, and I'm the only one in my family so far who has tested. But me and my siblings are very supportive of each other's decision to test. But I plan to share a bit about my own personal reasons for choosing to participate and some benefits that I've felt that I've gained from participating in research. So I know these wonderful women went over, some goals of ALS research, but I just wanted to share some goals of getting involved in research and just research overall, really through the eyes of a family affected. And so really many of you who are here. And so really understanding how disease develops and progresses, identifying early biomarkers, studying gene-environment interactions, building large open data sets and tissue banks, improving diagnostic and care tools, developing and testing effective treatments, personalizing care through precision medicine, expanding access to equity in research, and obviously the most important, we want to live our lives. And so when I started kind of getting into what research really looked like, I had to kind of wrap my head around, okay, clinical studies versus observational research. So my father wasn't really interested in doing any investigational drugs. He was a pharmacist himself. And so the way that he decided to participate in research was more so through the observational studies and studies that they had mentioned earlier. And that's also how I've participated in research so far. The observational studies really do help support future breakthroughs. And the participation in research is really meaningful, even if you're not in a treatment. And so I encourage you to think of research more so as like a spectrum and not necessarily a one-size-fits-all. And so if you're not necessarily comfortable with taking a drug or trying a gene therapy or something, there's so many other ways that you can have an active participation role in research and help the researchers better understand how this disease presents and how it progresses in a way that's very productive and fits what you're comfortable with. And this is a family photo from the most recent walk. That's my dad with his first grandson, Noah. He made it to Noah's first birthday, which was a goal for him, so he's very happy about that. So I know these lovely ladies went into, different types of research. I'm not going to necessarily list these one by one, but I wanted to put them on the screen just to also reiterate that ALS research participation really is more than just clinical trials. And so, yes, the interventional clinical trials, such as testing new therapies and treatments, are very important. But there's the observational studies, including the natural history studies that track disease progression over time, and the epidemiological studies that examine environmental and lifestyle factors. In terms of biomarker and genetic studies, so these kinds of things, for example, my father participated in his lifetime by donating blood, and the various programs that you get involved with, they understand ALS and they understand that it's difficult to travel. And so we've had phlebotomists come to our house and draw blood. We participated in one of the studies for microbiome. So we sent out our stool samples and they sent us everything that we needed. And so they really accommodate you in the situation. And a lot of the calls for getting enrolled were on Zoom. And so as easy as coming up next to my father's hospital bed with the Zoom call and, helping him through that call to get enrolled. And then also a lot of surveys and interviews. And so for myself, I know like I have on my weekly planner, I know once a week I fill out a survey on mental health and that is kind of tracking me at 28 through the rest of my life as an asymptomatic gene carrier to see, does mental health have a play in it? Once a month, I participate in a voice interview to see how, my voice at 28 might compare to my voice at 30 and 35. And if it potentially is changing even before we think that the symptom is onsetting at 50, 55. And so getting involved earlier, if you are listening to this as an asymptomatic carrier, really empowers you with the knowledge, and somebody is tracking you as well. And so, yes, it is heavy to have the knowledge that you're at risk, but by getting involved in research, you're also empowered and connected with leading researchers and scientists. For example, I have some twitching, and it's easy to say, oh gosh, is this that, and then when I go to my monthly or yearly check-in at these universities, and I have these leading researchers, I'm able to bring that up, and they're able to, assure me, no, that's not that yet, or we'll keep an eye on it. Thank you, I'll add it to your chart. And so I think it really empowers you with a lot of information. And then the last thing on this slide is contributing brain and spinal cord tissue post-mortem to advanced science. I'll go into that a little bit later. This is a picture I just had to share. My dad taught me how to do his haircuts, and I loved doing that. Now I save so much money, I don't have to take my dog to the dog groomer. So, like I said earlier, I supported my dad with enrolling in a lot of remote research studies. And so if you're listening as a caregiver and your spouse is interested in contributing to research, it doesn't have to be a big involved process of, traveling out of state and spending a full 2 days at a hospital. And so we discovered these studies by asking questions, being proactive, asking neurologists at our clinic, and then also going through a lot of platforms online. Obviously, there's barriers involved. When you have ALS, we understand that, there's logistics. We might have planned a Zoom call to meet with the research team at 2 p.m., but my dad is deep in sleep. They understand that kind of stuff, and they really work with you. And so from my experience, they really accommodate the fact that you're going through ALS. Also cognitive changes, as they shared, my dad did develop FTD, so that was a little bit difficult, and timing. But nonetheless, there was so many benefits. And I think one of the biggest ones was staying connected to hope. So my father enrolled in the Columbia Silence ALS program. And so I was also involved in the Columbia Families Project. So essentially his involvement in that was a long DNA sequencing to eventually have them work on a drug over the next X amount of years that could potentially help prevent symptoms forever, even presenting for me and my siblings, and then potentially even being a gene therapy. And so I think for him, that hope of knowing that what he was doing and continuing to live day to day, was contributing to something bigger than himself, and that would hopefully end up, changing my life, my sister's lives. I listed just a few trusted trial finders on here, but there's so much more. So clinicaltrials.gov, Neil's Trial Finder, ALS TDI, of course, Trial Finder. IMALS has a signal dashboard where you can search and they automatically have it. So it's ALS specific. And the legacy, I have to say, has been huge for me. And I just went through, looked at their research programs that they have out there and just started sending emails, getting involved. And just other advocacy programs. I really just encourage you to be curious and ask questions. You don't have to be an expert at this. It can seem really intimidating to break into research. But if you just reach out for support to other people who might have experiences participating, that can be really helpful. And joining support groups or attending webinars to stay updated can also help you understand where research currently is, where your involvement could really help propel things forward, and what might fit for your situation. So I understand this might be a little bit of a touchy topic, but I think it's very important to note. So my dad's final wish was to donate his brain and spinal cord to research. And obviously I can acknowledge that there is a lot of emotional, logistical, and ethical reflections when deciding on this. And again, it's such a personal decision to each and every person and family. And so please know, by me sharing my story, I'm not pushing for anything. But this was so important for my dad because he felt like he was still going to be able to contribute to science today and in the future, even beyond his life. In our experience, there was no cost to the family, and everything was set up in advance in a way that I knew exactly who to call and what to do after my father passed. And there was no delay to the funeral, and everything was in place. I would say that my biggest piece of advice would be to have the uncomfortable conversation in advance if this is something that interests you. I can say with the conversations that I've had with researchers and scientists directly, this donation is so integral for pushing research forward. And I'm really proud to say that with my dad and I's effort, we were able to have his donation sent directly to that same study I shared earlier, the Silence ALS program. So they are researching the TAR-DDP gene using my dad's samples. So I listed a couple ALS-specific donation options. These are just a start, but like I shared before, when you establish contact with any of these groups, I felt so overwhelmingly supported. Again, it's such a touchy topic. It can feel uncomfortable, but they really support you with the whole process. And having this set up in advance so you don't have to think about it, and having that empowerment of knowing that even beyond your life, you're contributing, I think really brought my dad a lot of comfort in his final days. Okay, so I don't have a ton of time left, which is very like me. My dad always joked growing up, Maggie, can you keep it in 10 words or less? So, and I never could. So I'll start to try to wrap it up a bit. But again, I come here with a lot of different perspectives, getting involved in research. One, watching my dad go through ALS and wanting to support him in any which way that he wanted to be involved. And so as a caregiver, and then also as a gene carrier myself. And so like I had mentioned earlier, I'm one of 4 siblings, and we all respect each other's choice and decision. And I think that's really important if you're listening and you're in a family where there is many people that are at risk. And I think getting involved in research also can provide you with a lot of insight into what it might feel like to receive these results. For example, the study that I participated in, I was provided with several sessions of genetic counseling before I was even completed the test. And they coached me on how to build my support system for when I did receive my results, so on and so forth. And there's also ways to participate as an asymptomatic gene carrier or somebody at risk. If you aren't ready to know your results, you can join in a non-disclosure group. You can also join as they said, as a healthy participant. And so if you are a caregiver and you're interested in giving back, keep that in mind as well. For me, getting involved in research and testing helps me feel empowered, connected, and informed. It helps me to contribute by being an advocate, raising awareness, and I feel like it's helped me to turn my fear into purpose. It shapes the uncertainty, and it turns it into something really useful. It's a very emotionally complexing decision to test, but it's brought me a lot of purpose and honestly greater healing in my life. It's changed how I see my life and how I see my time, my purpose, my energy, and what I choose to decide to put my focus forth. And so, there's no right or wrong answer when it comes to deciding to test. But I can say that if you are going through this decision, there is a wealth of support out there, such as in the Legacy and other groups. And I definitely encourage you to know that you're not alone in this process and reach out and get involved. I had to say free vacations on there because whenever I go for a research update, they cover the hotel, sometimes the flight. So I always try to make a fun trip out of it. The last time I went to UPenn, me and my sister went to a Billie Eilish concert. And I'm like, oh, Miami? That sounds pretty nice. Well, I haven't been to Miami. So there are lots of other benefits too. I'm going to wrap it up because I know I'm over time, but this is the last slide anyway. Again, research is not just science. It's personal and it's powerful. Every single one of us have a story, and the people that are leading the efforts, they need us to be able to participate and give our time and energy so they can push this forward. Please know that you can contribute to research without just being enrolled in research. You can contribute by supporting someone who is enrolled, helping somebody with enrollment. You can get curious and ask questions, and you can just stay informed. And so in whatever capacity that you feel you're able to, and right now in this way, know that you can get involved in pushing research forward. And I do believe that we're closer than we all think. And if we continue to push together, we will end this disease. Thank you.
Thank you, Maggie, for that very personal and informational speech. And also for someone who says she has a fear of public speaking, she really has done an excellent job the last 2 days. Thank you. We only have 1 or 2 minutes left for questions. I'm sure there are. Okay, we'll start right here. Can you talk into the microphone so everybody can hear you? It's right there.
Can you hear me now?
Yes.
I'm actually directing this to both of you. Is there a map of genetic carriers that you guys can work on?
I sure can do that. We can meet and talk about that. If I have the data, I can map it. That's the short answer. I'm unaware of other mapping, and there might be someone else doing it. I'm not aware of such a map. But Pat, did you hear that? I know you're on. Let's talk about it on Monday.
I don't really have a question, but a comment. I noticed in the one map that you're so proud of where you said this is where we are not getting results from people. I also noticed that that's the 3 counties that I live in near, and we also don't have an ALS clinic nearby. There's this huge corridor in Northwest Florida where, you have to go 5 hours to Birmingham or an hour and a half to Mobile or 5 hours to the Mayo.
Yeah.
I'm wondering if you've looked at that at all, whether that has anything to do with that lack of information.
I don't know the answer to that, but that's fascinating and why we do the map. But what I would say in response to your comment is it tells me that we need to do a better job of translation of so we're finding these things, we have these maps, and now let's act on it. How is this actionable? It's interesting. You can look at it. It's good for recruiting and things like that. But how does this trickle down into the people who are actually living in those areas that are not colored in on our maps? So I know, like I said, I know Pat is probably taking notes and making a list of things, but that's definitely something that we can look into for larger research projects for sure.
Maybe a quick question. Well, IMALS maybe a year ago was thinking about leading a project looking at exactly the problem that Cassie, I think you were talking about, where we as researchers are not allowed to share data or specimens, despite the fact that the sense is anyway that most patients would want those specimens that they give so dearly to be shared. So whether it's a fix on the front end, do we have a universal consent form that allows sharing, or on the back end, how can we fix this problem? Because it's a big problem.
So what I've seen is that like when I was at NIH, a lot of the newer protocols we were writing or the amendments, we would start writing that into the protocol language, and it would be part of the consent form patients would sign that like samples could be used for other studies later. The issue is that the older studies and patients who are completed on those trials, there's not always a way to reconsent them, or in some cases, you're not even allowed necessarily to recontact them, or like the IRB, the Institutional Review Board that approves the trial, like they want you to like get their approval to even recontact people on closed studies. So that's an issue that is more lies with, I think, the IRB and the legal climate around some of those older trials. But I will say that most of the newer studies now, they are building it in already so that samples you can approve if you're okay with your sample doing anything else. So I don't have an answer for the older studies necessarily, but I don't know, maybe that's something that advocacy and ALS can help work on legally to change that field there.
I just wanted to add real quick. I work in electronic health record data in addition to making maps. And a lot of times the way we get around that is called a waiver of consent. Because you collected your data or donated your data for clinical care purposes, and so it'd be totally impractical to go back and reconsent people. And I've done this for COVID studies and others. The challenge there is how much granularity then you're allowed to share in terms of dates and things, because that would all be these PHI or HIPAA identifiers, right? But there are ways of capturing some level of data prospectively for new studies, like she was saying. But yeah, totally agree. Like if it's not set up, if a pharmaceutical company collects data and it's not set up to share the consent form, it's very hard to convince them to share it unless they strip it of almost anything that, you know, maybe would be helpful in combining the data sets.
Seems like a good project for an advocacy group to say, here's a standard that we want all of you to meet if you're doing ALS research.
I think Juan had a question.
Not sure what he's saying. That's a scary thought.
This can affect research and access to care. To Ellen's point, if somehow we can convince states to make ALS reportable as a condition, perhaps we can release funding and convince our elected leaders that the funding is needed to meet the gaps that are created in service areas that are desert and enhance accessibility to patients, to research, and make them, giving them the resources needed to access research, such as travel expenses, etc. That's the biggest barrier, in addition to just getting out of the house, the expense of participating in research. If we can convince the states to report it, we might break down some barriers.
Good observation, Juan. I think we have time for two more before a quick break before Dr. Bedlack speaks. Dr. Bedlack, do you have a question?
So these questions are for the mappers. So the first one is, have you ever overlaid maps of where people spent most of their life with where the algae blooms have been over the past few decades? Because that's one of our theories at Duke, is that there's a toxin that comes from algae that might be causing ALS.
Yes. So yes and no. Actually, Pat and I are actively working in this area, and what we're interested in is capturing the right data point for the algae blooms. That's what we need to find. Well, also the people who live there, but that would be easy enough to find with clinical data. So yes, that has come to us a couple of different ways, not just where you are, but from other groups and things like that. So certain kinds of mills or paper factories or places where people live, where they suspect an outbreak and they'd like us to map that. But algae blooms seem to be something that there's probably a lot of data captured, but we're not quite sure which one to use. So Pat, put that on our list and we'll reach out to Dr. Bedlack and follow up about that. Yeah, that's come up a lot. A lot of people even have told me that they've moved for fear of that exposure as well.
And the other one was, so as you're looking at the performance of clinics, you have this rating system that you use, patients' opinion of what their clinic was like. Be interesting to look at some other objective measures of clinic performance. Like, for example, within the TDI ARC, do you ask the question, which clinic do you attend, or how did you hear about the ARC? Because I suspect there are some clinics where there's a really high percentage of patients who participate in those because their doctor explained to them why it was important. And there's other clinics where nobody participates.
Yeah, I've been with ARC since October, and I handle the electronic health record data that come in, and I know exactly where they're seen because of that, and that's absolutely a question. And also, are they being asked about clinical trials or offered, to participate in clinical trials? Is one. We are asking that question as part of our clinic survey, but also in the ARC, and I think that's really interesting to see if it was even discussed. And I can see the encounter notes and what their doctor writes down. And sometimes they'll say, well, we talked to them about natural history studies, observational research, or clinical trials. We have a screening visit for a clinical trial coming up or something like that. And then lots of times I don't see any of that, just anecdotally. But I think that's an excellent point. And I would love to see written documentation of counseling around some of these studies that were mentioned today. And unfortunately, I don't see it a lot.
One more.
Hi, thank you so much for your presentations today. They were very informative. Really quick question on the data piece as well. I know you're getting a ton of them. My question is around, once you have this data, I think you noted the translational, like the next step. Is there an infrastructure or a system in place where once your organization gets this data and gets this information, do you hand it off to the next group that works in that space? Is there relationships and connections already there? Or is that where we all as a community can step in and help build that infrastructure?
So we have the GeoALS, the portal when you can link to, and we have the cards that you can go to, and that has the maps. That's a place where you can visit the maps and play around with them. So we definitely have that. We, my daughter, who's our intern, and I go to the legislative affairs team meeting every Wednesday that we can for IMALS, and that's a big part of it as well, because you're absolutely right. The dissemination piece is so important. Getting people to use it, to comment on it, to say, what they didn't like about it, what they wanted to add to it. Just today, now we have a new map layer that we might want to add, like that. That's environmental, but that's why we need to have these conversations. So I think dissemination is probably something, like, we're a young organization, but something that we need to be actively working on and partnering with all groups to make them aware of what we're doing, and then making maps for them. That was the whole idea, is, you come to us and say, I have this hypothesis and we're not seeing anything in this area. Can you drill down and tell me what are the demographic characteristics of the people where we're seeing holes on your map? And that would be something for us to do and offer to you.
I was just where my mind started to brainstorm is, for example, in Florida, she mentioned the gap in care. Could we bring that to our legislative meetings and have this map printed out and have a conversation about access to care? And could that bolster our asks when it comes to our appropriations that we're talking about? It's the data that's available there, and is it getting into the right hands and in the right rooms? So thank you so much for the work.
You hear that, Pat? We need a one-pager. And then the other thing is, my daughter, Ryan, is for her internship, she's making a template. So this is really relevant. So she's making a story map template that's customizable for every individual advocate, how to put your picture, your experience, and your local map into a template. And then we're going to publish that as well. And I think that's really going to make a big difference. Thank you.
Thank you to all of our panelists. I think this was a really great discussion today.